So in this video, we're going to graph hyperbolas. So you'll notice that hyperbolas, at least the equations, look very similar to ellipses. The graphs are completely different, but the equations are going to look similar. So this is what a hyperbola equation looks like. So you'll notice the key difference between hyperbolas and ellipses is that minus sign. They both end in equals 1, but hyperbolas now have a minus sign in the middle, not a plus. So anytime you see a minus sign, that's going to tell you you're dealing with a hyperbola. You're dealing with graphing a hyperbola. Okay, some other common things that you see with ellipses. You see the x squared, the y squared, still have a squared and b squared. So a and b are still definitely a part of this graph. So we still want to identify what a and b are, still want to be kind of familiar with what they're going to do. Alright, to graph this, I'm going to set up my axes. Now, this first time through, we're dealing with an equation in which x squared is first. So all of this that we're about to do right now deals with when x squared is first. We still have a and b. And what I'm going to do with hyperbolas, I'm going to draw a rectangle. The width of the rectangle is going to be 2a, and the height of the rectangle is going to be 2b. So here's my rectangle here. The width is 2a, and the height is 2b. I'm going to draw diagonal lines through the corners of this rectangle. And these dotted lines are going to become asymptotes in this graph. Remember that asymptotes are, lines the graph does not touch or cross. So these dotted lines are asymptotes. The graph does not touch or cross these slanted asymptotes. So we can write equations for these lines, these asymptotes, and that has to do with a and b. Well, if you think about it, if you study this picture that I've drawn, rise over run is b over a. So the slope of this dotted line is b over a. The equation is y equals b over ax. That's the asymptote with the positive slope. The other asymptote, which has negative slope, has a slope of negative b over a. So the equation of that second asymptote is y equals negative b over ax. Alright, so to graph the hyperbola, you kind of want to know what it looks like first. And what it's going to look like is two parabolas that open away from each other. So when we're ready to graph, we're basically going to graph two parabolas that will open out. And recall from parabolas, what did we need? We needed a vertex and we needed foci. And the last thing you got to know is that since x came first, the two parabolas, as well as the vertex and the foci, they're all going to occur on the x-axis. So everything that you you want, or everything you get, the two parabolas, the vertex, the focus, they're all going to be on the x-axis because x squared came first in our equation. All right, so let's get and when I say the parabolas are on the x-axis, they go through the x-axis. All right, so our parabolas are going to go through the x-axis. And to graph this, we're going to want to know the vertices, and we're going to want to know the foci. There's going to be two vertex, one on either side, and there's going to be two foci as well. And recall from parabolas that we needed the A value, the B value, the C value to identify those points. Well, the vertex is at a comma 0 and negative a comma 0. And you can kind of see that from the rectangle, right? The edge of those rectangle is at a and negative a. So the vertex, or the vertices, plural, is at a comma 0 and negative a comma 0. The focus is going to be at c comma 0 and negative c comma 0. And you see those points, they're kind of outside of the rectangle. They're out on the ends there. So we got to be able to get c. So how do we get c? Well, c squared is a squared plus b squared. So c is the square root of a squared plus b squared. So now I'm ready to complete my graph. I'm going to basically draw these parabolas. They're going to go through the vertex. They're going to approach these asymptotes, but they're not going to cross. They're not going to touch. They're just going to get very, very close to those asymptotes. So I got one on the right, and I got one on the left here. So again, it kind of looks like two parabolas that are opening out from each other. Because x squared came first, these parabolas go through the x-axis. The vertex and the focus also exist on the x-axis. So this is the finished hyperbola. All right, so let's do an example here. So all those notes that we just took, let's try to apply all those notes and graph this hyperbola. So here's my equation. The key point that you want to identify is that it's minus in the middle, so that means we're doing a hyperbola. X squared came first. So looking ahead, the graph goes through the x-axis. The vertices, the focus, all on the x-axis, and the graph goes through the x-axis because x squared came first. Other thing that you want to also know with hyperbolas is a squared will also come first in the equation. So 9 is a squared and 16 is b squared. I know that with ellipses it was a matter of what number is bigger, but for here it's just what comes first. So based on this, a is 3, b is 4, a squared plus b squared equals c squared. So c is the square root of 25, So C is 5. So I have my numbers all identified. And again, just kind of pointing out that a squared will always come first. So a squared is 9, b squared is 16. So with hyperbolas, a squared always comes first. Okay, so using the notes that I gave you a moment ago, let's identify our vertex and our foci. So vertex is, or vertices are a comma 0, negative a comma 0. So vertices are at 3 comma 0, negative 3 comma 0. My foci are at 5 comma 0, negative 5 comma 0. So with those, I think I'm just about ready to graph. So I'm going to draw my axes here. So it's going to be important. Try to make your lines straight. Try to count your increments evenly in the x and y direction. We want our graph to look good. So I'm going to start with my rectangle. For my rectangle, the width is 2a. So the width is going to be 6. I'm going to go out 3 left and right. So now I have a width of 6 altogether. My height is 2b. So my height is going to be 8. I'm going to go up 4, and I'm going to go down 4. So here's my rectangle, and that's going to enable me to draw my asymptotes. Right? My asymptotes are going to go through the corners of these this rectangle. So I got a asymptote with positive slope. I got an asymptote with negative slope. And let's identify the equation of those asymptotes. Look back at your notes that I gave. The equation of that asymptote is y equals b over ax. Well, if b is 4 and a is 3, that equation should be y equals 4 over 3x. And from the rise and run, you can tell that is the case, right? That's 4 over 3x. That's the slope. My other asymptote has a negative slope, negative b over a. So negative 4/3 x. My rise and run is negative 4 over 3. So those are the equations of my two asymptotes. I should be able to also plot my foci and my vertices, because I know those coordinates, right? So I'm just going to label mine with a V and an F for vertice and foci. The last thing we got to do is just draw in this hyperbola. Remember that, again, the graph goes through the x-axis, when x squared is first. So let's draw this hyperbola. I'm going to approach those asymptotes but never touch. Same thing on the left side. Approach those asymptotes but never touch. And there's my finished hyperbola. So I'm going to go to my favorite website, desmos.com, just to see my graph on a nice graphing website. So I'll zoom in here to make it a little clearer. Can't really see right now. But I've graphed my hyperbola, and I've also graphed the two asymptotes to also show that, yeah? So I got my hyperbola in red here. I got my asymptotes as a black dotted line. So that looks quite similar to the graph we did on paper. So we should feel pretty good about that. Alright, another example here that I'm going to go through. Again, we're dealing with a hyperbola because of that minus in the middle. But the big difference now is y squared is first. So that's going to change things up just a little bit. Alright, so y squared is first. So that means the vertex, the foci, the graph, they're all going to be on or through the y-axis. The vertex, the foci, the graph, they're all on the y-axis now because y squared was first. Alright, so because of that, how is the vertex going to look as far as a coordinate? Well, it's going to be 0, a and 0, negative a, right? If the vertex is going to be on the y-axis, the coordinate needs to be 0, a, 0, negative a. A squared is still first. So for this problem, 16 is a squared. So my a value is 4. So my vertices are at 0, 4 and 0, negative 4. How about my foci? Well, my foci are at 0, c and 0, negative c, right? Because those coordinates are on the y-axis. I'm going to get c the same way as I did before. C is square root of a squared plus b squared. So c is the square root of 16 plus 4. Square root of 20 is about 4.5 or so, 4.47. So the location of my foci are 0, 4.47 and 0, negative 4.47. Alright, so similar process as before, it's just everything is now dealing with the y-axis. Okay, so I'm going to get ready to sketch here. So I'm going to set up my axes. And first thing I'm going to draw here in a moment is my rectangle. So another key difference when y squared is first, my rectangle is going to have a height of 2a and a width of 2b. So that's a little bit different than before. So my A value is 4, my B value is 2. But now my rectangle is going to have a height of 2A and a width of 2B. And in a moment here, I'm going to give you some slides that summarize all these notes so you can kind of have a guide for when x is squared first and when y squared is first. So here's my rectangle with a height of 2A and a width of 2B. So my overall height is 8 and my overall width is 4. I'm going to draw in my asymptotes through the corners of this rectangle. So the equation of these asymptotes is also different. So I'll give you a little side note here. When y squared is first now, the equation of the asymptotes is going to be y equals a over bx and y equals negative a over bx. All right, so going back to the example that we were doing, trying to write the equation of these asymptotes. Well, if a is 4 and b is 2, this equation is 4 over 2x, which simplifies to 2x. And we can see that in the graph, right? That line has a rise of 4 and a run of 2, so its slope is 2. Same thing with the negative slope of negative 2. The graph, the foci, and the vertex are all going to go through the y-axis. So now my parabolas are going to open up and open down. So I've drawn in my vertices and my foci on the y-axis. So here's my hyperbola. It opens up and it opens down. It approaches those asymptotes but doesn't cross. Alright, so there's my final graph. Alright, so here's a summary of what to do when x squared is first. Just pause the video and add it all to your notes. And here's what to do when y squared is first. Again, pause the video and add it all to your notes. Having those notes handy when you're doing problems is going to help you out a lot. So one more example we'll do together, and I'm going to use all those notes that I just gave you. So whenever I write something down, it's because of those notes. Y squared is first, so I'm dealing with that portion of the notes. A is 4, B is 3. To get C, I'm going to do square root of a squared plus b squared. So square root of 25, which is 5. I'm going to identify my vertices first at 0, 4 and 0, -4. I'm going to identify my foci, 0, 5 and 0, -5. I'm going to get my axes set up here. And I'm going to start with my rectangle. So if you remember in the notes that I just gave you, since y squared is first, the width of the rectangle is 2b and the height is 2a. So that means my width is going to be 6 and my overall height is going to be 8. So here's my rectangle. Once the rectangle's in place, I'll be able to draw my asymptotes. Looking back at the notes I just gave you, when y squared is first, the equation of the asymptote is a over bx. So that's 4/3 x and negative 4/3 x. And that should correspond to the slope of the line you drew. My vertices and foci are on the y-axis. And there's my hyperbola opening up and down. Alright, so kind of a lot to it, kind of a lot going on. It just takes practice. You gotta do a few, gotta follow those notes, but you'll get the hang of it.